Now we've got P of x over Q of x greater than 0. Yes? Yeah, I mean, that's going to be part of the x-intercept, right? So I need to now find my x-intercept. So I set the top equal to 0. And that one you can factor 2 out, but you can just move the 26 over and divide by 2. So x is 13. Yeah? No, it's positive. Yeah, because this comes over, it'll become negative, and then you divide by negative. So vertical, 8. And so I'm only going to have 3 test points. X-intercept at 13, a vertical at 8, which creates 3 regions that I will test. And I will test them into the original one right here. I'm going to test them right in here. Be careful though, we're testing to see if this answer turns out to be bigger than 3, right? Not bigger than 0? Bigger than 3. So let's test a number over here, like, how about 0? Isn't 0 over here? And then over here, let's do 10. And then over here, let's do like 20. Going crazy, huh? How about 0? What do you get when you plug in 0? 2 over, yeah, see, I'm not going to this one, I'm going to this one. 0 here, you get 2 over negative 8. 2 over negative 8 is a negative number. Is a negative number bigger than 3? No. So that's not going to work. Okay, how about 10? Be careful here. 10 on top is going to give you 12. Over 10 on the bottom is going to give you 2. 12 over 2 is 6. Is 6 bigger than 3? Yes. 20. Plug in 20, you get 22 on top, and on the bottom you get 12. Is 22 divided by 12 bigger than 3? No, it's not. 24 divided by 12 is 2, right? So definitely not bigger than 3. So it's not going to work. So my answer should be everything between 8 and 13. And I will not include them, right? Not include them? Because it was strictly greater than. It did not include the equal. So the final result is 8 to 13. How is this? I mean, I'm not quite sure by your reactions. Okay. There's no surprises, okay? There's nothing, there's no craziness coming or anything. All right, so how about this? Let f of x be equal to the square root of x minus 7 over x plus 3. Hey, well, hold on. What is wrong with you? I wasn't going to do this, but you were saying it was easy. No, I'm kidding. This is like a homework problem. Now look. Okay, yeah, so why would we need to do any of the stuff I've shown you today? Because in a calculus class, we're going to want to try and sketch this function to have an idea of what it looks like, right? This, would you agree, this is definitely not a function that you cover in college algebra? Yes. I mean, we can do a rational function, right? We could graph this for you, couldn't we? Yeah. That would be an easy problem on a test if I said sketch that. But we have not dealt with that. So in a calculus class, you would say, well, first of all, What's the domain of this function? Where is the function even defined? So when you talk about domain, this is a completely different topic, right? You look at, okay, do I have a square root in there? Yes. I always know that I can never take the square root of a negative number, right? Right. So I know that whatever's under there must always be what? Greater than or equal in this case, because that could equal 0, right? Square root of 0 would be 0. Greater than or equal 0. Right? So this problem saying find the domain, that problem with that question really turns into this problem, doesn't it? And this problem is what we just did. The answer to this would be the answer to what the domain of that is. You see? Now, we also have one additional thing, though, that's not included. Well, no, because we're going to get our division by 0 here. So never mind. Scratch that. So we go through this. How about I just draw it for you? Here's 7. Here's -3. We would have a vertical here. We have this here, right? And then you test some things. Where are my 3 regions? Here. This would work. This wouldn't. This would work. Pardon me? It's not that complicated of a function. I mean, it's not that complicated. Okay, I'm sorry. Yes, I'm just saving us time. All right, so that's it, right? What's weird about this, what students kind of mess up on, is they say, wait a minute, you're saying that some of my answers can be negative, right? Like, look at this. Your interval is -infinity to -3 union 7 to infinity. That's what the solution to this would be. That's the domain of this function. It was strictly. It was not strictly. So what would we include? 7. Yes. Thank you, Nathan. See? You did that in your head, right? It's all.
That's what threw him off.
All right. So that's our domain, right? So people think a lot of times if you ever have a square root, you can't have a negative number in the domain. That's not the truth. I mean, the truth is that this whole thing together can't be negative. But that doesn't mean I can't plug in a negative value for x. Let's take something in this interval, like -10. That's in here, right? I can plug -10 into this, and it should work. What's -10 minus 17? -17. What's -10 plus 3? -7. What's a negative divided by a negative? Huh? I'm plugging in -10. Sorry. -10 minus 7 is -17. -10 plus 3 is -7. Negative divided by negative is positive. The square root of a positive number is doable. I don't know what the answer is, but the point is that just because you have square root in a function does not mean you can't plug a negative into the function. You just can't have this thing underneath the root turn out to be negative at the end. We call this thing underneath the root the radicand. So the radicand can never result in a negative number, else you're in trouble. Radicand. Okay, that okay? That problem? There's one like that in your homework. So it just turns into this, you get your interval. And so this answer is your domain, you're done. I have another question. F of x equals x to the 4th minus 1. G of x equals x minus 1. I'm giving you 2 functions, right? And you could graph these, right? You could graph that f, and this would be a polynomial function, wouldn't it? And this one would be a line. Here's the question I'm asking you. Find where f is below g. So if you graph these two, I would like to know where the f function is below the g function. So less than it, right? That's what it means to be below it on the graph. So really what this question translates into is to find out where f of x is below g of x, yeah? That's the translation of the question into the math. Do you agree? Yes. Okay. Now, what is f of x? 4 minus 1. Where is that less than? And what is this? Polynomial inequality. And how do you solve a polynomial inequality? All to one side, left and right behavior, plot, sketch, figure out where the answer is. That's your answer, right? So I'm going to move everything to one side. I think that's all I get, right? I subtract x on both sides. I add 1 on both sides. I get just this. And this ought to be interesting. What is the left and right behavior of this thing? Because this is our polynomial function. It's up, up. All right. What's the next thing you're supposed to do? Factor that out, right? So can I pull a GCF and x? X cubed minus 1 less than 0. Uh-oh. What are you going to do with that? You want to do synthetic on that? Yes. You could. Just remember, you don't have any zeros in it. You don't have an x squared and you don't have an x. So if you're going to do synthetic, make sure your synthetic has a 1, 0, 0, negative 1 in it. This is also a difference of cubes. So you can go straight to a difference of cubes formula. Right? Isn't that a difference of cubes? I'm going to go straight to the difference of cubes. And we all know that that's what it turns out to be, right? Yeah. Sure. Okay, so just a quick show of hands. How many of you knew the difference of cubes formula by heart? You just know it. You know it? No? Okay, there's a few maybe. If you don't know it, that's okay. You just need to know where it is located somewhere in your notes. Is that a question or a response? You know it? Okay. So you would have gone straight to that? Then my question now is, can this factor? This is a very important point I'm about to make, all right? This right here. If you ever have a difference of cubes, all right, let me write the difference of cubes formula down here so you have it. I'll do it for difference. It's x minus y, x squared plus xy plus y squared. That's the formula for a difference of cubes. If it was plus, it's cube. The only difference is that's a plus, that's a minus, and this last one never changes. In both formulas, it's always plus. Right, that's the difference of cubes formula. That's the sum of cubes formula. So listen to what I'm about to say. If this formula, right, if this formula always spits out a quadratic, if that quadratic was factorable, don't you think they'd give you a frickin' formula that was already factored then? Like, don't you think they would factor that for you and break it down even further? You know what I'm saying? You would think? They don't, because it's not factorable. And it never will be factorable. So you're guaranteed if you ever employ the difference of cubes formula, if you ever utilize it or use it, you know that this quadratic is not factorable. I could double check it for you real quick by just looking at if we try to set it equal to 0 with the quadratic formula. Remember this part of the quadratic formula? Remember, anyone know what we call the b squared minus 4ac? Bonus points? It is the radicand. It is. That is a correct answer because it is a thing under the radical. But the b squared minus 4ac in the quadratic formula has a very special name. It's called the discriminant. Have y'all heard that before?
Oh, you would have just given me like 2 more seconds.
You had it, huh? Okay, well. The discriminant is a very important value because if the discriminant is negative, then you know you don't have any real solutions. And if you look at this right here, b is 1. So you get b squared, there would be 1 minus 4 times, now look at a. A is 1, C is 1, so it's negative. Unless A and C were both, they weren't. So it's done. You know that won't factor. So that's it. We are done with factoring. That's as far as it'll go. So since that's as far as it'll go, I plot my x-intercepts, which are where? 0 and 1, and there are no others, right? Because there's nothing that's going to come out of this. I'm going to do what at each of these? Up. Don't need test points for polynomial inequalities. Cross or touch? Cross at both? And all I need is my left behavior, or my left and right behavior from here. So it's going to go up. It's going to look like a parabola, isn't it? And what region am I interested in? Where it's less than 0. So I'm interested in this. So my answer is parenthesis 0 to 1. Now, interpreting this answer into, going back to what this thing was asking, it gave us two functions. F of x was x to the 4th minus 1. It gave us another function, g of x was x minus 1. And we were saying, hey, when is the f function below the g function? When is it lower than it if you were to graph the two? And it turns out that it would be lower between 0 and 1. Oh, wow. That's not correct. Forgot to move it down. So if you were to graph f of x, that's what it would look like. It would look like a parabola. All right? That's what it would look like. If you were to graph g of x, here's what it would look like. It's a line, right? Y-intercept of -1, slope of 1. So I go to -1 on the y-axis. I go up 1 over 1. It would look like this, right? And we were asking ourselves, where is the f function below the g function? And you can tell from the picture that if you look between 0 and 1, that's the only place that that black function is below the red one. Outside of that, the black one's above the red. Black one is above the red. But we could do all that without actually looking. Now, why would you want to know that? Because in Cal 2, what you're going to want to do is you're going to say, take that region right there and revolve it around the x-axis and find the volume of the solid that you create. All right, so first of all, if I take this region right here and I wrap it around the x-axis, what would it look like? Okay, so imagine this whole sheet of paper coming off, taking that little region and just like whoosh, around the x-axis. Would it look something like, three-dimensionally, would it be kind of like a dome-looking thing like this? Maybe? Like wrapped around, but it would be, on the inside, it would be kind of like hollowed out. Like you'd be able to put your hand in on the inside of this, wouldn't you? Yep. Do y'all see it? I don't know if you see it or not.
Looks like an eye. So where's that section from? The section you have colored on?
What? Okay, yeah, I know that looks weird. Hold on, let me try a better picture. Let me try a better picture.
I see the beginning and the end point.
Try a better picture. Okay, let's look at that. Does that look a little bit better? Does that look like almost like half of a ball? Half of a sphere? Half of an egg. Does that look like half of an egg? Yes? Half an egg? Okay. If I take this, if I just take this piece right here, this black piece, and just rotate it around the x-axis, do you see I would get this?
Oh, yeah.
Do you see that?
But where does like the other like the oval?
The axis is right here, going right through the center of this. Because I'm rotating this piece right here. No.
Why
Because there's no formal thing between here and then, there's no formal thing to get you to practice seeing things wrapped around axes. You see it or you don't. So look, if I take this region and I imagine this line and just pivoting this whole thing across, up, through, back into the board and back around, I would create this object, wouldn't I?
Oh, around the,
The x-axis, all right? So I can't really do it easily. I have animations I can show you that would do it, but I wasn't ready to do it. So you wrap that around, right? And you create this three-dimensional solid. Then you have to imagine that it wasn't just that. It was, I really wanted you to do just this piece around. And so that what that would do is that would create this like hollowed out point. So like I could put my hand inside of here, but I couldn't go straight through because it's going to come together at the tip at the front. Very weird shape. And so what we would ask in a Cal 2 class is what's the volume of that object?
the volume of that triangle.
Of the solid. Of the solid. The sphere with that piece cut out. It's not even a sphere though, because it's not, this isn't the equation of a sphere, but yeah. Yep, one day, not yet. But knowing where, you know, an easier question, a much easier question, maybe I shouldn't have started with that. Would have been this. Would have been, instead of finding the wrapped around, just to find the area. Like what is the area between those curves? That would have been a little easier to maybe visualize. Like, calculate that area. But you have to know, like, you have to know where the functions come together and where one of them is above the other and below the other. You have to know that in order to find the area. All right, well, Cal 2, that's still a ways out. Yeah, the homework. I really wish I didn't do E or F. Okay, let me talk about E and F. I'm not going to write them on the board. But if you were to do E, what would be the first thing you do? Move everything to one side. Then common denominator. Then you go through the process, right? Okay. On F, factor, you're probably going to have to use synthetic division. I wonder if you're going to have a hole in that one. I'm thinking you might have a hole. You just make sure you don't put that in your answer. Yeah. So let's try the homework. Try the homework. I've already looked at the homework myself for both the 10th and 9th editions. See how you do with it. If you have any questions over the homework, I'll address those when we come back. What, next Monday? But the homework out of the syllabus or out of the schedule is good for 5.4. We only have one more topic, and then we have our test, because our test is what, next?
Wednesday.
It's next Wednesday, is it?
No.
The following Monday? Let me see.
This is the updated one. The 28th?
Next Wednesday, 21st?
Yeah.
It's scheduled for next Wednesday. No, what was the division? No, we covered all that when we were looking at them. Properties would be like, you know, they're smooth. I did talk about them. They're smooth.
I'm just making sure we didn't have to move them over.
So which homework was from Monday?
Hold on.
So we don't have to go back.
You don't need to go back and do them. No.
What was, Monday's homework was from this?
Monday's homework.
Like,
And it was, and you could do it, right? Yeah, I said do that.